Alright, so what I have here, I'll be doing some soldering. This is the retro Maplin thing that Big Clive found, and as far as I can tell, it's some sort of continuity tester using a Darlington, I think he said it was an MPSA 14 transistor pair. It's not quite the one I have, but I was able to find some parts in the scrap bin to make something similar. And for a twist on it, I'm going to add a little lipo battery, PTSC to protect that, but otherwise keep the design pretty similar. I have a project box prepared here, a couple leads, tiny circuit board, and a battery. And as far as I can tell, this shouldn't take more than 15 milliamps or so. And that's on the outside for an LED of this size, more like 10 to 12. And this is supposedly 180. Even if it's not actually that capacity, it should be plenty. Most of the trick is going to be fitting everything onto the circuit board here. I'm going to at least attempt to use this little 1" by 1" Schmaltz Tech proto board, and that should fit nicely under these connectors here. Then I have some cutouts for the charging port, which will sit underneath, and power switch. So this will just tuck in there. One lipo cell connected either to the charging port or over to PTSC. And then one lipo cell connected alternately to the charging port or over to the PTC, and then these two plugs on the front. The green one will be connected to the positive through a 100K resistor, and the black one will be connected to the base of the Darlington pair, as well as pulled down through a 1 meg resistor to negative on the battery. And then I have a small 200 ohm potentiometer for tweaking the LED and sort of controlling the sensitivity. I did test this on the breadboard and it worked well, so it's just going to be a matter of reproducing it here and, to make sure that I keep everything connected correctly. Call this the positive side. Didn't want to fold that over like that. Hopefully that's still alright. And then, so right now I'm working on this joint between those two, and I'm thinking I could bring resistor all the way across. Maybe that would be the easiest way to do it. And then it could come out this end, and that's going to be coming up to the green plug. So this lead here, here, it's going to go to the switch, and then this is going to be green. Coming off the middle here, it's going to be the LED. And let's see, looks like on this, I actually have this on the low side, but I do intend to put it on the high side. That should fit in. I'm not sure if I think I want this to stick through, and then I'll probably glue the LED into place. Let's see. It's also pretty hard to tell which side is which with the leads on these. I have a bunch of these little LEDs. And they're not bad, just a little hard to read. And the other side of the LED should come to this potentiometer. Actually, I think I might mount this one on the bottom. It's a little bit larger, and that will actually make it accessible in the future. Future adjustments. So. Bend these without jabbing them under my nail. Again. Looks like it'll stay. This may get lifted up a little bit more. That's roughly the placement there. I suppose if I bend this one flat, then I can probably place that through, and that will actually sit pretty neatly. I suppose it would be placed like this, which then lines up this resistor nicely on that side. The LED through there pretty well centers the board, so that all seems acceptable. Now I just need to fit this transistor in. And let's see. This is pulled down. I want that to actually join the middle pin of the potentiometer, because this 120 to 130 is actually a 200 ohm potentiometer. So bring that I want those to join, but I actually think I want to pull down on this side so that the resistors both come out to the same place. And then take that on further to ground. Okay, so this resistor is here, and then because, let's see, make sure I have this right this time. So this point is actually going to come into the transistor. It's not quite ground. It was when I had the resistor on the low side. Putting the resistor on the low side means that the resistor has to come off the emitter there. So how can I put this together? One moment, please. Alright, I think I have the placement of the 1 meg resistor. I'm going to put it next to corresponding with 100K for now, so that the plugs are both easily accessible. And then it brings it quite close to the LED, but I may move the LED down a little bit. I'll have to look at that. First is getting this in place, and just to make sure that I have everything right. Green is this one, so it's going to be the base, and then positive with this base collector emitter, BCE, pretty standard layout. And the only place that's really going to fit, probably here. For reference, this is a tip 31C. No idea if that's a good part for this. It's just one of the lower amperage parts that I had laying around. Anyways, so this is the base here, and the base needs to meet the 1 meg. So if I put it in this way, I'm not sure if that will really be ideal. This way around is going to put the base on the outside, so that will be sort of easy to bring the 1 meg resistor around and just hook it up to the outer pin here, and then positive in the middle. It's possible. It's not going to be super easy, but a positive will be over here, so you can bring that across, and then the positive is also coming in here, and then that will put ground directly in line. So I think I like that, just because it's going to put the ground where it needs to be, and then bend the others. Let's play that out a little bit. The only concern now is fitting this all in, and it's definitely not going to fit if I lay this flush. This is going to have to lean over. Not too far. No, it is too far. But this is going to be rotated this way anyways. That's just going to sit down a bit like so. So that still puts it potentially out of bounds. I may need to see if I can move these resistors up slightly, or not fold this over quite as much, because it needs to fit the LED. It needs to fit in here. It seems like that is pretty likely to fit. It feels like it's alright. So it's close. Not a ton of room there, but I think it will work, especially because these things can be wiggled around a little bit. And let's see. charging circuitry needs to be on the side as well. And that's where things are going to get pretty snug. But I think that will be okay because the transistor pair is going to be sitting down lower, and even this is going to be the lowest part. If it's a problem, I can sort of set that out and then have the transistor under it. As long as they don't directly conflict. Let's see if I can get this in place without it completely falling apart. Okay, so that's pretty close to in place. And then this, so that is definitely in the way. I might have to tweak this, push it over the other direction. I think pushing it the other way will probably work. There's room on the board. And that will put it a little bit close to the potentiometer here. So maybe I will replace that with a fixed resistor. I guess it depends on how much of an issue that becomes. So this is going to force it to sit pretty much straight. I don't want to go bending it back and forth repeatedly. So, placing it over here is going to move it away from all of the components it needs to connect to. I don't really want to do that. I could move the potentiometer and put the potentiometer over here. It's not ideal, but I think that is going to be a better placement overall, just because there's sort of some room, and I may even be able to put it in diagonally or otherwise get creative with it. But that fits pretty nicely. Actually, I like that. So let's say the potentiometer is going to go on this corner instead, and that is, again, the 120 to 130 resistor for the LED. I just want to be able to tune it based on how strong this battery actually turns out to be. I did give it a quick test, and it was able to maintain a pretty good 3.7 volts. Okay. And then if this contact with the LED is going to be a problem, then I will just put some Kapton tape over the back. But this needs to be folded down. I'm going to do that without breaking it too badly. Okay, this is not the best thing for these leads, but I'll wiggle this out a little bit and then try to lay it fairly flat. There we go. Something like that. And then bend these back in place. Alright. Minor revisions later. Have most of the resistive components on the front here. No, that's not true at all. That's a resistor too. Anyways, have most of the small components on the front and the two larger, taller components on the back, which actually fits really nicely. And then the resistor side is this way, because the resistors are going up to meet two plugs. And then so that fits through, and that all sits very nicely now. Actually, I'm much more pleased with that. I can even sort of just tie all the grounds together right there. And then power and ground will be coming out on this side, as these little markers, Sharpie markings, indicate. So that will be over here. And then I won't have any trouble fitting this with the switch, like so. I plan to either super glue or silicone glue the switch in place once this is a little bit more complete. But everything will sit just about like so. LED indicator, 2 contact points on the front, and power switch and charging port right there. Gonna have to take a break, probably come back to do the soldering later, but got everything laid out on the board now, and I think I have my wires and battery prepared, so it will be quick. Solder this together and get it tested out. I haven't tested with this tip 31C, and I'm not exactly sure what the gain is on that. Simulating this, the pair of, I'm not exactly sure which model I used, generic NPNs, I think they had a gain of about 100 apiece. I put 2 of them in, so 10,000. That resulted in getting a couple milliamps through the LED at about 3 mega ohms between the 2 plugs. So it starts to see a signal or some amount of continuity at about 3,100,000, and then bringing that down into the 1 to 2 million range, you can get quite a bit of brightness. So just sort of a generic continuity tester. You can put your fingers across it and it will light up, but you won't feel a tingle or anything. You can put both hands across it, it will still pick that up. Depends on how sweaty your hands are. Very dry hands don't work as well. So it's a little toy sort of continuity tester. I don't know what else to call it. Handy device. Something you may eventually need. I'm going to build one just for fun. Three, two, one, go. Alright, getting back into the Maplin thing that Big Clive found, making my own lithium-powered one. Got the schematic here. All the parts are in this project box. A little bit of a mess from drilling it out, but get everything soldered together. And let's see if it works. The last time I placed all of the components on the board, I did not take too many notes on how this was going to go together beyond just the layout of the actual board here. So hopefully I can get this put together correctly. That will be the exciting part. Attaching 2 sense resistors. One of the resistors is a pull down, the 1 meg pull down over here, and then the other comes off of the positive line after the PTC. So the positive resistor, which in this case is the blue one, is going to go on the green side. Demonstrate hooking that in like so, and then the LED needs to line up. So once the 2 resistors are hooked in like that, then the next step is to line up the LED, and that's how the board will sit. I think that looks pretty good. If I want to keep the tip 31 away from this contact, I could put the board between them, but I can also just put some Kapton tape, some vinyl tape on there. And then yeah, that'll fit nicely. So some soldering to do. I'm going to start with the pins on the more substantial rear mounted parts, I think, and then move on to some of the smaller components in the front. Don't think I'll be blocking myself. I guess this one does block a few components. I need to make sure the LED is in the right direction as well. So I'm going to get to that. I'll try to explain some of it, but not all of that is going to be explained, I imagine. First, I need to grab some solder. Alright. This is going to be tricky with such a small board, but make something work. Hope that they actually apply enough solder. Just want to tack these two down a little bit. So that will let me line that up. Then I'll probably move on to the potentiometer. Alright, so that's those two components in place. Now the transistor and PTC, and then I have really just the LED, it's the one left in the middle. So I may or may not, I think if I put the transistor in place like this, it may actually be beneficial to solder it, and then I can bend it back later. So I'm going to do that. Alright, so that should have that in there pretty well, and that is how I want the leads. So just take the tweezers and bend that whole package flat, flush at the end. Bend these down for the moment. Now PTC is really the positive input here, and I actually think I want to move that one a little bit. So bend some of these up, and then this would be the PTC. I've already bent these quite a bit. I don't want to put too much more stress on them. It looks like this one is starting to crack a little bit, but not much to do about that now. I guess I could get another one. Alright, so I'm going to pull this back out to give it a little bit more space this time, so we can bend it over nice and safely without putting too much strain on the leads. So do that one up there, the other one comes back here. And this I really want to hold in place while I solder it down. As a temperature sensitive device, you really don't want to linger too long on these, or any resistor, or most capacitors, and basically everything else. Alright, now I have an LED tester somewhere. I suppose my primary battery powered multimeter has a diode mode. test this, and I made a mess of those legs. Alright, I'm going to solder down these other two resistors and then get the LED into place as well. And then some more on the PTC. Only did one leg of that. Let that cool off a little bit. And the other leg. Perfect. Alright. That's all of the primary components attached. Both resistors, and those will very much come into the center. May or may not need the screen wire. I think I'll use that just to go from the 1 meg to the base. And then the last thing that I really need to do is get the LED plugged in here. So first figure out the polarity on that, because I want to keep things sort of simple. I want to put the positive side of the LED between these two. So it's going to go here. Okay, so it looks like positive is on the left. I would say so. Flip that around. And you can tell which side is which based on the interior of the LED as well as the length of the leads. But with them bent up like that, figuring it out from the length is a little bit difficult in my opinion, and why not test it? So just to make sure, this one should be the negative, and positive should be, this is going to be tricky to do. Positive should be this one. Perfect. That's what I'm looking for. Let's turn that off. Okay, so that's all of the pins in place, all of the through-hole components through their holes. So now I have to actually do the wiring between them. And this is a good gauge for the power plug, which already has its own wires, and the power switch, which is going to need some wires. But for the internals, especially between the 1 meg and base here, I'm probably going to want some finer wire. So I'm going to grab that off the shelf. This kit should do the trick. So this I recall being VCE, and on the schematic, base, collector, emitter. So want this middle pin is going to come to potentiometer, and that could go, it's a potentiometer, so I just need to use 2 pins. It doesn't really matter what the order is. I'm going to take base here. It's probably going to come to the farthest pin, because that will make it, let's see, if I use the outer 2, I think that will make it a little bit easier. So, collector is going to come over here. Base needs to come to the bottom of the 1 meg. No, base needs to come to the top of the 1 meg where it connects to the plug. So let's do that before I forget. Should really put this board on the helping hands. I'm going to have to make room for that. Alright, a little bit of a mess, but should do the trick. So, with this board, taking the green wire from the sense side of the 1 meg resistor, don't really want that connected to the middle. I'm going to keep those separate because this is fairly sensitive. Once it goes through the Darlington, the amplification is quite substantial, so probably desolder that a little bit in the middle. Looks good for now. And then this one needs to come over about yay long. And that is going to come up to the outermost pin of the Darlington transistor that I have, a large package. Put this around. I'm going to try and tuck this under the lead a little bit. I think I've soldered it down too much. There we go. Alright. A little bit of extra wire, but should be fine. am going to start clipping some of the extra leads off at this point. Send those pinging across the room. And then this one also needs to be clipped on this end so it doesn't come in contact with that middle pad at all. Oh, right. Set this one off. Okay. So that is mostly connected. I need to connect the emitter here out to negative. Because the negative is going to be a piece of wire. I actually need to connect a couple other things to the negative as well. The base of the 1 meg is going to need to come across. I think that has enough lead that it probably still can, but it would cross a couple other things in a problematic way. So that needs to be bridged on this side. Just going to use a small piece of wire with most of the insulation intact. So this little piece of wire is going to come across there, and that should provide the negative pull. Yes, Ham. Stop yelling at me, buddy. Alright, I think that's ready. So now that is lead, the tricky one to place. Alright, I think that should do the trick. Just such a small space. Alright. So now I need to hook the collector here up to the potentiometer over here. That one's actually going to be a little bit easier. It's a much longer run. This one's going to be tricky because I've already soldered to both of the surrounding pins. I need to do this middle pin without touching either of the others. Probably could have done those in a different order, but too late now. Bring this in from the side. Beautiful. Alright, that should come to the end of the potentiometer. Bring this across, down like so. And that should lie nice and flat. If that becomes an issue for the LED, I'll just bring it around the other way, I guess. But it doesn't look like it's much higher than the PTC. And it will actually provide some nice cushioning on the front. And then you bring the negative lead of the LED down to the potentiometer. So that's actually going to be interesting because potentially put that in, not backwards, but not ideal. So if I clip off both of the resistors, let's see, this one needs to go to positive, and the LED positive is over here. So this is LED negative, and this is 100K positive. That's the issue that I'm running into right now. So this one needs to come across and connect sort of like that without contacting anything else. And this one needs to come around and get in touch with the potentiometer. Should probably use the tweezers for this rather than the other device. So I think I'll move the blue one over here because this is going to be much easier to bring around this way. And that actually avoids contact with pretty much everything that could be problematic. This is the 1 meg on this side. Oh, so that's actually messed that up a little bit. These two are supposed to connect, which is perfect because they're right next to each other. And then this is the one I was actually meaning to clip. So I did that wrong, but it's fine. Clip that off, and then this. Alright. I can snip that. This is the positive lead of the PTC. Again, bring that over as much as I can. Probably going to end up being right here. That's plenty. That's going to come to the base of the 100K, which comes out here. This is the 1 meg. This is the green plug. This is the black plug. That's right. And then this is the bottom of, this is the negative lead of the the LED. Just space that out a little bit better. Okay. I think that's ready to solder after much fiddling. And I know that puts the blue lead and the LED on the same pin, which is not right. So we move the blue lead over here. Hope I have enough solder just to tack that down a little bit. Perfect. Add some more solder to that one in a second. Okay, the LED is there and there. So now I need to solder the PTC, considering the inside lead of that to the LED and to the 100K. So that's those three pins. They'll connect to one another, and then the other end of the LED comes around to the adjustment. That all looks correct. The adjustment then comes to collector. Base comes up to the black plug. This is the green plug. This is the negative coming out. Alright, a couple more leads to clip off now. And I think this can be shortened somewhat. The length of that was actually giving me some trouble. This lead from the LED, I think it to sit a little bit flatter here. Okay, it's good enough for the moment. And then I'm going to need to put some Kapton tape to keep those all separate from the transistor. And then the blue needs a little bit more solder on it over here. Let's get a nice bead of solder for this to sit in. Maybe a better angle to solder it from. There we go, that should work nicely. Okay, and then that will sit nicely in the gap here between the resistors and the LED. The other one I am really tempted to shorten it, but I guess it will sit off to the side. That's fine. So I think that is the circuit board, more or less completed. A few things I need to flatten down, and a few solder joints to put in place still. So now, make sure this fits. It looks good to me. So that will fit nicely right in there. And just twist this back around. For the moment, I'm going to connect the power plug, and then I am actually going to power the board, test it before I go too much further. Make sure the secret smoke does not come out, because, yeah, I haven't really tested this one. definitely don't need all of the wire on this side. I tested this design on breadboard before putting it onto the proto board, so I know the design and the components generally work, but there was no written design for the proto board version, so hopefully everything is still connected correctly. I probably beep it out with continuity on some of the major joints, pins, before I actually fire it up, but either way, going to need the power lead. So alright. So now for some continuity measurements. I'm just quickly going to beep it out and make sure all of the important stuff is connected correctly. So based on the schematic here, power switch is not in place yet. So the PTC should have continuity between, let's see if I can test this. There we go. Okay. Alright. So that's power plug is correctly connected. Now this leg of the PTC should connect to the 100K, as well as the positive side of the LED, as well as the positive side of the LED. The 1 meg on the upside here should connect to the base of the transistor. And the other side of the 1 meg should be the general negative. And that, now let's see. So emitter is here, and that is connected directly across. So this black wire represents this link. The 1 meg is there. And then base, the blue wire represents, hang on, sorry, green wire represents this link. And then the blue wire represents this link. Okay, so blue, green, and then this pin is directly connected to the black wire. And then the positive side here, I don't know if I can easily get at the negative of the LED. That should be connected to the potentiometer. Okay, looks like everything is connected correctly. So I believe it is time to give it some juice and see if the secret smoke comes out. going to try and clip these around. This is not the most reliable way to do it, but I'm not sure where my other plugs got to, so let's just go like that for now. I think that'll work. Make sure this doesn't get melted. It's cooling off quickly. And if this works, I should be able to just sort of touch these or bridge these with something metallic, and the LED will light up. Hopefully there's no smoke anyway. Alright, so that is power applied. I don't see fire yet. That's positive. On the other hand, it does not appear to be working. Definitely not working. Alright, was that something I missed? Or is that an issue with the power? Luckily, I have a voltmeter here. Now let's see. So using the negative there. Have not. There we go. So there is voltage on that side. And then I just saw if I bridge these over a little bit, it does light up. So did I mix up these two? Let's see. This might be a CBE instead of BCE. Why is that? Oh, I'm not reading the right pin. Okay, so voltage across the LED. So that's good. Okay, let me double check the pinout on the transistor. I may need to flip the blue and the green wires. That won't be a big deal. Okay, now according to the schematic and the data sheet for the TIP 31, this is correct. Base, collector, and emitter. Base, go to the 1 meg, collector, and emitter, and the ground. So, what did I do wrong such that bridging these two is causing it to light up? So now if I actually connect the two leads, maybe I should have tested sooner, it does light up. If I lick my finger and touch it, I get a fairly shaky connection, call that. it's definitely doing something. So, let's see if I turn off this. That does make it a little bit easier to see. Okay, I think that might be responding correctly. So it comes on at full brightness when those two are bent together. So it was just making things up. Interesting. Even when I'm not touching the positive, just touching the 1 meg makes it illuminate slightly. Wonder if that's coming through ground or how that's working. I'd have to look at how my power supply is plugged in, to be honest. Okay, it looks like this gadget is working correctly. So undo this without tearing it apart. No resoldering needed. Just need to get it in place. And it still needs the power switch and battery. So that's going to be the tricky part now. So to power this, I want to take, and this should actually be the charging lead. So this isn't going to plug into the board on the positive side at all, actually. My switch has vanished under my helping hands. So the switch and the charging lead will sit sandwiched like so. Going to try to arrange the arms to allow that. And this one will need to come something like that. Well, this one should be just slightly under. And then the positive will actually connect to one side of the switch, while the board connects to the other, so that one position is charge and one position is use. And that will mean the charging port is live, but it's a protected port, so I'm not too worried about that. It's not like this needs to be waterproof anyways. Alright, and then I have this teensy little battery that will fit somewhere in that mess. So the battery, the positive on the battery is going to connect to the middle of the switch. One side of the switch will connect to the PTC, and one side will connect to the charging port, and the grounds will always be in contact. So I actually need to pull this wire off of the PTC. That was just for testing. This is going to fold back on itself. And I need to apply some solder to the switch. Alright, those are tinned, so now this needs to come in contact with the red lead, the power plug, the charging port, we'll call it. Seems secure enough. The other side should be connected back to the PTC, and the battery goes in the middle. Of course, once the battery is connected, this will all be a little bit more dangerous. Although this is not a particularly high discharge battery. I actually got these little cells for use in Hot Wheels, RC Hot Wheels, but they don't quite have the discharge for the motors that I wanted to use, so that was a bit of an issue. I may put some heat shrink on these pins. They are pretty far apart and not prone to bending, so I may also just wrap them with tape. It will help if I connect the wires to the correct pins. This one's supposed to go on the outside. And then the other side is going down to the PTC. Now, attaching the battery to this, the best way to do that is going to be with it in charge, in the charge position, because it's not going to be anything plugged in. It's just going to be going to an empty pin at that point, so it should be fairly safe. That's in charge, and this is actually not the most convenient position, so I'm just going to grab the wire. And I think the negative side of this, let's see, if I want to put the battery in, I'm not exactly sure where I want to put the battery in, probably on top actually. So the battery leads should probably be longer, at least the positive one. I think the negative one is going to be okay, because that will allow it to sit. I don't want it to sit directly behind the ports, but it could sit up at the top, and then the leads could come down. I think that will probably work nicely. So I'm going to do the negative. If it needs to sit sort of up here, I think the best place to connect that is going to be the middle, the negative of this point here. It's close enough to the schematic. Question is whether I can get my soldering iron in there anymore. If I lift this wire up and over the LED, that actually makes a lot more room. Makes that a lot easier. And then I can just tuck that in, and the other black wire came out of place. Alright. I'm going to need to lower this whole thing and then hold the battery in place, I think. Getting both of these wires soldered in here is turning out to be a little bit of a nuisance. Alright, if that worked, that should be attached, and that should be attached. Perfect. And that should allow the battery to sit quite a few spots all the way up like this. Now I need to connect the positive of the battery to here, and that is going to be a much longer run. So before I do that, I'm going to place it into the case again. Move the wire back. These two need to be in contact with their posts. Line up the LED on the back, slot that into place. Alright, so that leaves the battery currently with enough wire to sit, actually right here is basically perfect. I don't think the discharge from the battery is going to interfere with this too much. So if the battery sits right about there, then my power switch probably has too much wire, because that is supposed to sit on top. So these need to be adjusted a little bit because the power switch is supposed to be actually tucked in like that. And that's not going to work at the moment. Alright, getting closer though. Worried about the length of the leads on this power switch. The battery leads are actually not so much of a problem. But this one is entirely too long, and I need the charging port to sit under the switch. The switch is sitting awful close to the PCB, proto board, the board. So the switch is sitting awful close to the board. And that's not the worst thing for the positive pin, but the other two should definitely not be in contact with the board. So I'm going to need to trim these two down and then find a way to tuck the charging port on top of this whole mess, which probably means bringing it in between like that, and then over something like this. It's a close quarters, but I think that's probably the best it can do. So with this layout, I think it will make sense to have charge on this side, because I can solder this across, and then this one over here will be, this side will be on. So, let's see what I need to cut down to make that happen. Okay. It does look, if I want to use this switch, it looks like I'm going to need to trim off at least this middle and usage, middle and on, or battery and on. This is probably a job for the heavier snippers. Okay, this is going to be a nuisance to solder, but that can't come in contact, so on needs to come over to this side, and battery will go to the middle. I'm debating whether I should clip down the third one for charge. It's probably best. This might actually be easier if I take this out and adjust the red wire, so I can change the angle on that. Especially if I put this in a helping hand. There we go. Alright, let's see if that makes anything easier. Slide this into place again. Battery in its position over here, and then the power switch is going to plug into this. So that's going to be close, but I think it will work. Let's see if I can tin this without melting the container. And then onto the switch. It's not perfect, but no, it's not even going to hold the wire in place. Alright. Well, I may need to tape some of this in place just to hold the switch while I get everything soldered down. Alright, I'm going to have to flip this around. I don't want to have any chance of soldering under that tape. And then this arm should hold the switch in its place, if it will fit. Yeah, it seems like it will. And this can hold the other end. Alright. Now I have to get this wire connected to, of course, the most difficult pin to possibly connect it to. So let's see if that can be done without melting this tape. I'm thinking I maybe should have used this finer wire. I guess it's not too late. See if I can negotiate this out. Alright. Yeah, so let's replace this with a piece of finer gauge wire and see if that makes life any easier. I have a habit of using too heavy of a gauge for a lot of the power supply type pins. Just use a heavier wire, it won't melt, but also won't bend. Sometimes you need it to bend, so it can be an issue. actually going to leave a little bit more wire this time because I think that will help keep it from bending too tightly. Let's give it a little bit more distance, bend radius. So that is tinned once again and ready to place. Just need to get the LED to fit into its spot. There we go. And this wire should actually be under the switch. It needs to come around like that. And then that can be pressed into place. Alright, now this wire will just come up and connect there, which is going to be quite a bit easier than what I had before. Looks like it has contact. Alright. So now it's time for the charging port over here. I need to get the helping hand at least holding, maybe just holding the pin of the switch will be better. If these will line up with each other, at least. Close enough. Alright. Just bring that over. Let's under this one down as well. Alright, so that's the charge port and the power cable. And only a couple things left to do now. There's the actual sense leads and the battery itself. I think it's probably time for the battery. Make sure this is turned off or to charge. And I'm going to try and place this once again. Make sure everything fits nicely. And then see if this come around on the outside. I think this is probably going to be better if I bring it down the middle. Alright, this is the one that shouldn't really touch stuff. This is the fun lead. Interestingly, it's also slightly melted, just sort of from the factory, like that. Not sure what that's about. Alright, that's the battery installed. No immediate fires. And I don't know if this is visible, but this is a chipped battery. It's a DW01 and the corresponding MOSFET chip. So that will sit just like so. That whole assembly will sit in there. And I think it's time to solder these, and then there's some taping to do. So for these two, I need to make sure that the LED is in place, and it is. And just get a nice bead of solder on either side. About like that. Alright. So now that is very much held in place by the solder. Probably tighten these down a little bit, but that's off to a good start. I might put a drop of glue actually on those nuts just to keep them in place, or thread lock. I guess that is glue for nuts. Definitely going to put a drop of glue on the LED so that it doesn't push out or become an ingress for any kind of water. Probably time to check voltages with the battery in place. So now this is in charge mode. And make sure that that is in fact hooked up. 3.7 on that side. Good. And then if I flip the switch, no immediate explosions. Also good. Negative of the charger should still be hooked up. And green should have 3.7 volts on it. Perfect. Now that is protected through the PTC, which, I forget which one I grabbed. I want to say it's a 12 or 120 milliamp hold, 120 milliamps, 3.7 volts. It's a third of a watt, so not a whole lot of power going through there. Let's see if I can turn this off. Probably mark the on and the charge with a paint marker. This is really nice for a lot of things that you want to put a battery into. And then you can get enough contact, enough surface, there we go. Just paint one side of the charging port red and put a stripe down the switch. So that will indicate the on and the positive and the on. And then I think the last thing to do to get this all packed up, put some tape across there and fold the transistor down. I want to get this tape under the charging lead and then bring it diagonally across everything else. Something like so. And then this will fold down just like that. And that will actually help hold the battery in place a little bit. So like that. And all of this will come together with the power switch there, charging port there. And these need to be glued in place still. But let's see if this works. Power on. I can see that. I don't know if the camera can. Yeah, it's sending a little bit of current through my thumb. See if a piece of solder will get any better results. Oh, that's nice and bright. Alright, well there is a very small lithium-powered continuity tester of some kind, rechargeable, supposedly very handy, but I don't really know if that's true. I'm not sure if anyone knows if that's true anymore. But here it is, and it works. Totally just thrown together from parts in my spare parts bin. Really wanted to see if this design did anything, and it certainly does. It lights up an LED. What more could you ask for? Alright, so here it is, all finished up. Turn off the light again and give it another test. Make sure that's on. So, the original design from Big Clive was a pair of AA batteries generating 3 volts. Didn't really have any safety circuitry because you don't really need it with the AA's. They're not going to do a whole lot of damage. Of course, don't go eating them, licking them, throwing them in buckets of water. That might still go poorly. But you don't really need a fuse on a pair of AA's. So 3 volts, a pair of pads on the end of a pen-like device, and then it used an MPSA 14. And mine uses a tip 31C, maybe not the best Darlington, but it's the one I grabbed. 200 ohm potentiometer to allow you to tweak the brightness of this a little bit, and I kept the same resistor values here. The voltage was similar enough that I thought that would probably be okay. It seems to work out. There's a power switch going between the actual circuitry and a charge port with a very small 180 milliamp 1S 3.7 volt lithium polymer battery in there as well. To protect that, there is a PTC, and I need to check the trip current on that, but it's 120 milliamps hold. So this is a chipped battery, the DW01 charge and discharge protection chip, but in addition I have that PTC, just making sure that even if the battery is discharging at about 1C, that will be enough to keep this tripped, so I don't think this will let the battery explode. But always good to be careful when you're working with lipos, especially the unnamed, unbranded ones. I'm going to keep this turned off when I'm not using it, and make sure that keep it charged up. Just a little bit of gluing left to do on the switch to keep that in place. Pretty happy with how that turned out. The reason I put the ports on the front, test that before in the video, plug in some leads like this, turn this back on, and if I bring these in contact with each other, it lights nice and bright. So you can use this as a continuity tester all sorts of ways. Just go around testing whether things have any kind of continuity and if it would stop falling over. It also works through your body. It's only 3.7 volts, so it's not really pushing a lot of current. You certainly can't feel anything, but even just coming in contact with it a little bit, the more you squeeze, you can actually get a gradient on that. So that's pretty neat. Very high gain. I'd have to check exactly what the gain is on the tip 31C, but yeah, it's definitely a neat device. Thanks for watching. See y'all later.